Alright, let's take a look. This one's a little bit more tricky, but I think it's still doable. The Taylor series for a function f about x equals 1, so that's the center, that's the a value, is given by that thing, and converges to f of x for some r value, where r is the radius of convergence. That's great. Find the radius of convergence r. Find r. Find r. Find r. How the heck do you do that? Well, that is by using the ratio test. The ratio test is used to test series to see if they converge or diverge, or maybe they're inconclusive. But you can also use the ratio test and set it less than 1 to find out that radius of convergence. To find the interval of convergence, you check the endpoints. That's all that means. So let's first use the ratio test. So that means we got to see what a sub n plus 1 so is. We first take a look at this. That's a sub n. So what I'm going to do is, since this is a fraction, I just write the a sub n plus 1 first. And every time I do that, I rewrite stuff. So actually, instead of writing negative 1 to the n plus 1, plus 1 plus 1, that's the same thing as negative 1 to the n plus 2, which is the same thing as negative 1 to the n times negative 1 to the 2. Because when you multiply and you have the same base, you add the exponents. And I use that every time, so it's easier to see what cancels out later. So that's what I'm going to do right now. I'll just erase this. So what do I mean by that? I mean when I plug in an n plus 1 here, I get negative 1 to the n times negative 1 squared. Now that just goes away, because negative 1 squared is just 1. And then instead of 2 to the n plus 1, I write 2 to the n times 2. I'm skipping a step, but it goes a lot quicker. And then also x minus 1, instead of writing it to the n plus 1, I write it to the n, and then also times it by that, because that's to the 1. If I have the same base, I add the exponents. And then I still have the denominator, the absolute value, n plus 1. Now, that's the first part. That's this. And then I'm going to divide by this, which means flip it over and multiply. So I will just copy this down, except for it's flipped over. So n is on top, everything else is on bottom. And again, I do the same thing. Instead of writing n plus 1 here, I write negative 1 to the n times negative 1, and then 2 to the n, that stays, and then x minus 1 to the n. Well, now this, hopefully you can see why I do that. Because now the negative 1 to the n cancels out. Sweet. The 2 to the n cancels out. Sweet. And the x to the n, or the x minus 1 to the n, cancels out. So I'm left with very little, very few terms. So this is equal to 2 on the top, right? 2 x minus 1 times the negative 1 on the bottom. So I guess I can make that a negative 2. And then what I like to do is group the ends together, because that's what I'm going to end up taking the limit of. So there we go. I have that. And if I take the limit, this is part of the ratio test. If I take the limit as n approaches infinity of this part goes to 1. So this is equal to that. Now, for this to converge, I need to set it less than or equal to 1. So that's what I'm going to do. So by the ratio test, this has to be less than or equal to 1. And then I can just further simplify. The absolute value makes the negative 2 become a positive 2 on the outside. I can bring that on the outside. And then I just have x minus 1. I don't need the parentheses anymore. X minus 1 less than 1. And again, it's asking me, look, I'm almost there. I'm almost at this. I need to find r, which is the radius of convergence. So what I'm going to do is divide both sides by 2, and I get the absolute value of x minus 1 less than 1/2. So r is 1/2. Now, to find the interval of convergence, I would say like the 1/2 there, and I would add 1 to both sides, or to all three pieces, and then check the endpoints. That's finding the interval of convergence, but to find the radius of convergence, it doesn't ask you to check. Whoops. So we just have r equals 1/2. There, I'm done with part A. Part B says, find the first 3 non-zero terms and the general term of the Taylor series for f prime, which is the derivative of f about x equals 1. So I need the derivative of this. And that's actually very, very easy. So let me write that down and we can start on to part B. So I need to figure out f prime. But I can just take the derivative just like normal. Here's what most people miss. This is the most important part right here. Right here. Look at this. You look, hey. This part, all of this, does not involve x at all. Which means when we start plugging in n values, this is just a number. Means it's a coefficient. When we take the derivative, coefficients just stay the same. We leave this alone. We leave it alone. So f prime of x, this part, well, I'll write down the sum, and I keep that part exactly the same. Now this has an x involved, so here I can actually take the derivative. Remember, the n's will be numbers, so I can just use the power rule and actually chain rule, but the chain rule, it's like you're multiplying by 1. So the power rule says you just take the exponent, when the exponent is just a simple integer or a number, it doesn't have to be an integer, you can bring it down. So I bring down the n, and then x minus 1, so the derivative of the outside with the inside the same, so n minus 1, because I subtract 1 from the exponent, times the derivative of the inside. Well, the derivative of the inside is just 1. So there we go. That's f prime. Bam! Easy, done. Except for I want to simplify a little bit because the n's cancel out. And that's f prime. So what did it say? Find the first 3 non-zero terms and the general term. Luckily, this is the general term. So we're done with that part. Now I just need to plug in stuff and find the first 3 terms. I don't even need to simplify that. So this, I'm going to say, is equal to, and then start with 1. And I kind of like to do this. That's my index n. Start with 1. So I plug in 1 here, and I get negative 1 squared. Negative 1 squared. So that goes away. And then 2 to the 1, that's just 2. And then if I plug in 1 for this part, I get 1 minus 1 is 0, x minus 1 to the 0 power is just 1. So the first term is 2. Sweet. And then my n is 2, so I plug in 2. What is it? What happens to there? Well, I get, if I plug in 2, I get 3. So that's negative 1 to the third. That's just negative 1. So I'm subtracting minus 1 times 2 to the second power. So that's times 4. So I'm going to change that to a 4. That's ugly.